Let's take a look at the instructions for Homework 2. Homework 2 will give you some experience in text pre-processing using NLTK. What you'll turn in is just your Python file, the .py file, and you can use whatever IDE you want. Let's take a look at the instructions here. First thing you'll do is download this file from Piazza. This file contains the text of one chapter of an anatomy textbook. And keep that in the same folder as your Python file, so we won't have any data folder in this homework. Use a system argument to hold that file name, and if the user didn't include the system argument, print an error message and quit. Then you'll read that file as plain text. Then you'll tokenize it and calculate the lexical diversity. Lexical diversity is the number of unique tokens divided by the total number of tokens, and it's just a measure of the richness of vocabulary of a document. So for example, a lexical diversity of 0.05 means that 5% of the words, nice typo there, in a text are unique. So I'm asking you to print the lexical diversity formatted to 2 decimal places. You can find an example of that in the GitHub. In the data structures, all the way at the end, I demonstrate how to use an F string. We won't be writing to a file, we'll be printing to console. So again, the F string just has F and in quotes the string. And then when you want 2 decimal places, you give the name of your variable, colon, and then 0.2f. Next, you're going to write a function to pre-process the text. And there is a pre-process example in the GitHub that has a lot of these steps in it. So what you're going to do is first lowercase the raw text, then tokenize it, and then write a list comprehension to reduce that token list to only those that are alphabetical, not in the stop word list, and have length greater than 5. So what we're doing is we're finding important words in the document. Lemmatize the tokens and use set to make a list of unique lemmas. Do part of speech tagging on those unique lemmas and print the first 20 tag items. I have an example of how to do that in the GitHub. So what we see here is you'll have to look in part 2, this notebook right here on part of speech with NLTK. And all you need to look at is this first code block here. We have some text, and then we tokenize that text to get a list of tokens, and we send that list of tokens through the part of speech tagger to get our tags, and then we output the tags. And you see what you get here is a list of tuples where the first item in the tuple is the token and the second is the part of speech. In the next step, we're only going to be interested in the nouns, and notice that noun part of speech is NN. There's also a plural NNS, and there are separate parts of speech for proper nouns, singular and plural, but all of them start with capital N, so that'll make it easy to extract just nouns. And that is step D. You could use a list comprehension to extract a list of those lemmas that have a part of speech that starts with N. Output the number of tokens that you got after step A and the number of nouns that we just got from step B, and that's actually what you'll return from this function. Back in the main routine, you're going to make a dictionary where you have the noun and the count. So in other words, you're going to run through that list of nouns that you got from the function, and then count the number of times they occur in tokens that you also returned from that function. Sort the dictionary by count and print the 50 most common words and their counts. Save these most common words because we're going to use those in step 5 for the guessing game. So the guessing game, you'll start off giving a user 5 points, and the game ends when their total score is negative, or they have a way out if they want to quit. They can guess exclamation point as a letter. So randomly choose one of those 50 words in the top 50 list, and you can see the random number here. In the GitHub, I have a folder called Extra Material and a notebook that shows you how to get random numbers to index into your list. Alright, so you choose one of those words in a loop here, and then output to the console an underscore for each letter in the word. I actually output underscore space, so if it's a 6-letter word, you'd have 6 underscores separated by spaces. Prompt the user for a letter, and then give them feedback. If they guess right, add 1 point to their score. So I just added 1 point, even if, let's say, the letter E was in there 3 times, I just gave them 1 point. If the letter is not in the word, subtract 1 from their score, and then print some kind of message and let them guess again. So this guessing loop will end if they guess the word completely, or if they get a negative score. And you'll also keep a cumulative score for the game as a whole, and in the game if that's negative. Alright, down here we see that most of the points are for this game, step 5, and here's the sample run here, but let me also show you a sample run in the program. Let me hear it run. And if you don't get the same numbers I do for lexical diversity or the same most common words, that could just be an artifact of doing the pre-processing in a slightly different order. We're not looking for exact matches in the solution, we're just looking that you went through the steps. So now we're playing the game. It says guess a letter, and you see my original 5 points now had 1 added to it. So you can see the word here was relaxation. I got feedback that I solved it even after a few typos. Gives me my current score and lets me guess another word. So as you're working on your game, you can always cheat and look back up here at your most common words to help you out. Hope you have fun with this game.